we pulled Holly in, so I appreciate it very much. And so welcome, team.
Yeah.
Appreciate the time and appreciate your flexibility to meet with us, and a little bit later than planned. So maybe you can just start a little bit for our Q&A. Just give us a small overview. What is your target altitude? What is your motor type? And what is your payload?
Sure. Well, our target altitude is 10,000 feet. Our motor class is type M, and also our payload is a nanotechnology-based sensor for measuring air pollutants.
Okay. And the motor, it's a commercial off-the-shelf motor, or have you built your own motor?
It is a student researched and developed solid rocket motor.
Okay.
We develop our rocket motor.
I see. And have you flown this rocket before?
No, we have not.
No, only simulations.
I see. What about engine testing? Have you done any motor testing, static firings?
All right, so in regards to that, we're a pretty new team. So of the actual design of the rocket motor, we haven't been able to do any static fires. That's mainly been due to certain issues we've had because of the COVID-19 pandemic, partially because we couldn't get somewhere to test and we couldn't get support from our university. And since we also knew that the competition would be a virtual format, we decided we would save some of those resources so that we could compete and get a more competitive package next year.
Sure. Okay. Understand.
Could you tell us a little bit about your motor? Oh, sorry.
No, go ahead, Holly. Yeah.
Could you tell us a little bit about your motor?
Yes. All right. You want to go?
Yeah. First of all, our motor is based off a solid fuel right now, and our motor is designed to be out of metals because of the facility. As our new team, we want to go with aluminum. So the new motor, we don't go with alloys, so it's more easy to develop a new system with materials that we can malleably use without the knowledge of the alloys in other circumstances, like in the predictory rockets.
And then the propellant. So that's a solid propellant. Do you manufacture that though?
Yes.
Okay.
Yes.
And so I'm not sure, when you're saying that it's your motor is aluminum, are you saying that the casing's aluminum or that you're using aluminum powder in your propellant?
No, casing aluminum.
The casing's aluminum.
Yeah,
okay. What is the actual propellant manufacturing process?
Okay, we developed a casting equipment. Our propellant actually is potassium nitrate sorbitol, and we use compression to make this solid, the grain, sorry, of the propellant.
So we actually make the mixture of the grain acids, and then in the process is so with the compression of different coils, we making the actual solid grain acid propellant.
Okay. Have you or well, let me ask, what type of grain are you proposing to use, or have you thought that far?
We have our design.
Have you done like a?
My bad.
No, go ahead.
Oh yeah, I was just gonna answer that. We're using a Bates geometry. There are 4 Bates grains in the rocket motor, and we have spacers in place in order to ensure that the end surfaces do ignite and produce the curve that we expect.
Yeah. Okay. Given that this is your very first SRAD motor, have you flown your rocket design at all with a COTS motor or anything like that to test it?
We have not, again, due to limitations due to the COVID-19 pandemic, but in our original schedule, we had placed a test flight with a commercial motor in order to validate the aerostructure systems and the avionics systems.
Okay.
And
And-
do you?
Go ahead.
It's always hard to talk over each other, isn't it?
There's that
Zoom.
delay.
Everybody has Zoom fatigue. Do you have plans to conduct testing then? I'm not sure what the current state with returning to school and being able to perform some tests in this calendar year before 2022.
Sure. Actually, the Tecnológico in Monterrey started operations since 2 weeks ago. So we're expecting to conduct all of the testing we have sent in the document. First of all, we have to reassure that we have the materials, buy them, and also like to rescale all again prior December. We expect to have all the tests and later like refinement of the design and the motor. So we expect to finish all that prior December 2021.
Okay, very good.
So with that testing, are you planning on doing like subscale testing of the grain or
Yeah.
COTS?
Yeah, we started with the subscale testing and also acquiring a commercial off-the-shelf motor in order to ensure like that, as Diego mentioned before, to ensure like the integrity of the rocket. And afterwards, we aim to test our Strat motor.
Specifically in terms of the development and tests of the solid rocket motor, we're planning on doing about 3 subscale tests. The first 2 to characterize the propellant and get all the exponents and the constant of the burn rate. And then last test to validate the mechanical design. So that one would have much lower safety margins in order to ensure that we are doing the mechanical design right without building an entire flight motor.
Also, due to the fact that the payload, for example, is based on different components and needs to be tested under special conditions, we're planning to go to the laboratories this summer and start working on the nanocompositions that are needed in order to make our sensors work for the air detection.
Okay. I just a quick question on your fins, because I know time is short here. I noticed that you did essentially static testing, just side load and drag loading calculations. How fast is what's your top speed for your rocket? And do you anticipate any issues with fin flutter, or have you looked at that?
Okay, so we have looked at that. Our maximum expected velocity, I can't remember exactly what it is, but it's around Mach 1.2. If the motor performs nominally, it'll likely be more around Mach 1.1, which is all right because of our air brake system. So we can have a little bit of performance error from the motor. And in terms of the fin flutter analysis, we did the analysis on paper using the equations from, I think it's NACA. And we've had a safety margin of around, I think 1.5. So we'd have to go like Mach 1.8, which is pretty difficult. So we should be clear there.
Okay.
I had a
very good.
question about the experience and or mentors with others who have developed a solid motor before and actually mixed and cast.
Oh,
Actually,
okay.
I don't know.
All right. So in terms of someone from the team doing it, we have a couple members, I'm among them, that have been working with solid motors for a little while. Part of what we're doing is following previous procedures very well. There's a master's thesis specifically on KNSB, and we were following the procedures there to basically schedule all the testing program. And we do have a little bit of experience, but we have also been consulting with other people from the rocketry community and other teams just to make sure that we get those tips and tricks that are usually not in these types of documents.
Yeah, we base the majority of our information. It's like, as Diego said, is from one of the thesis, a major thesis, experimental investigation of solid propellant characteristics from NC Oldie, and another is the NACA's experimental website too. So we can get some values of some real values and base our creations in that information.
And also, well, specifically, we are in contact. I think it's team 96. It's a team from Baja California. They have prior experience doing research in rocket propulsion and developing rockets. So we've been in contact, and then we're expecting to visit them like the other side of the country for gaining like more insight or having like more communication regarding the construction, design, and build of a rocket. And if COVID allows it, they can come also to Monterrey. So we expect that soon.
Excellent. Okay, very good.
Yeah. Yeah, because that especially for your solid motor, it's really good to be able to have somebody to go to school on, and you should also reach out to try to find one of the AAA experts on solid on making propellant to give you a real good give you some pointers on that deal.
Yeah, also one of the nearest AAA jurisdictions is actually in Texas. So we expect like to visit them once the border is open. So
yeah, very
hopefully
good.
soon.
Yeah, for sure.
I was going to ask about your payload with just a couple of minutes. Well, 1 minute left. I know we're short on time. Briefly describe what your payload is and what is its mission.
Yes, thank you. Well, the payload, as mentioned before, is a carbon sensor, a carbon nanotube sensor that is intended to detect chemical reagents on the air. This can be useful, for example, in future space colonies or in control for just getting like a clean environment when we meant to, and also for controlling pollution. So it is pretty useful. And the way we're doing this is that, well, carbon nanotubes tend to start losing their properties as they get in a higher altitude when they're exposed to more extreme conditions. So what we did is that we reinforced them, we increased their capabilities using nanotechnology, and we made a whole new kind of sensors that is pretty innovative. And its mission is to last longer and to detect more faster the contaminants and the pollutants in the air.
Okay.
Very good.
And you entered the payload challenge?
Yes, we did. We actually made a little resume of our research, and we're conducting the physical proofs this summer, so we're pretty excited about it.
Very good. Okay.
Outstanding.
Any last thoughts or comments?
All right. Well, our time is up. So
yeah.
Any last words?
Well, on behalf of Team 86, we really thanks for the opportunity of being here at the first SA Cup. I mean, it's new for us, and we expect to learn a lot, fly rockets really soon, and hopefully the Exploding Flying Breed is going to be on the 22nd edition of this competition. So we'll see you there in the process.
Well, very welcome, and I'm glad we can. This is a challenging virtual environment to do this in, but anyway, I hope that you enjoyed the rest of the time.
That's fantastic. Really, thanks.
Okay.
Thank you very much.
Thank you.
Goodbye.
Okay. Thanks a lot.
Thank you.
Thanks for the experience, guys.
Such a pleasure.
Such a pleasure too. Bye.
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 Thank you.